All right, we are already in the last unit or last lesson of Unit 8. We are going to continue practicing with solving equations in exponential form and logarithmic form, but today we're specifically going to look at something called the natural log. So before we jump into this, just a few reminders. We talked last week about the number e. Remember that e is a number and it is approximately equal to 2.71828. The inverse of y equals e to the x, it gets its own special logarithm, ln for logarithm natural. I think it's the Latin form of that, but the ln is the inverse of e. So whenever you see an e, think ln. That means that ln also has a base. Remember, the common logarithm has a base of 10, so the natural log has a base of e. And the same properties of common logarithms also apply to natural logarithms. So let's see how this could help us. First of all, applying properties. Write 5 ln 2 minus ln of 4 as a single natural logarithm. So the first thing I'm going to do is take care of the exponent of 5, and I'm going to move that 5 to be here. So I'm going to get ln of 2 to the 5th minus ln of 4. And I can write that now as a single logarithm because when I have a minus in the middle, what operation am I doing between 2 to the 5th and 4? I'm dividing. So I'm going to rewrite this as ln of 2 to the 5th over 4. And then I can do, since those are all numbers and no variables, I can do some simplification. Ln of 32 over 4, which gives me ln of 8. And that is written as a single natural logarithm. So try this one. See what you get when you use the properties of logarithms. All right, so I moved this exponent, or this 3 that's in front, to be an exponent. So I get ln of x cubed and then ln of y. And because this is a plus in the middle, I am multiplying them. So that is using those properties with natural logarithms. Now let's jump into some equations. If we're asked to solve this equation, we need to start by identifying the base. And so the base of ln is always e. It will never be anything else. Never, ever. So since this is starting in logarithmic form, even though it says ln, remember that's just a special log, it's still logarithmic form, I need to change it to exponential form. So I'm going to put my pen on the e, spiral across the equal sign, and then back across the equal sign. This is going to give me e to the 0.1 equals x. I'm going to get out my handy dandy calculator. I'm going to do some evaluating here. Oh, you can see the camera. Okay. Oh, that's awkward. Okay. Second e to the 0.1, enter, I get this answer. So I'm going to put that x equals 1.1052. And remember, we like rounding to 4 decimal places. So that would be the whole problem. All right. So what is my base here? My base is e. So I'm going to make a note of that to myself. And when I spiral this, what am I going to get when I write this in exponential form? If I spiral this, I'm going to get e to the 21st equals 3x minus 9. Now, we're going to see a unique problem here because when I go to do e to the 21st, I'm going to get a pretty big number. Now, your calculator may write it out like this for you. Your calculator may also give you like 1.3188, etc., e to the something. And I'm not going to be too picky on how you write that, but I'm going to, because I know what it should be. So don't stress it if your calculator gives you something different. I am going to take the time to write all of this out, though. So then I'm going to add 9. And this is where it's so nice to have a calculator, because instead of typing all of that in again, I can just hit +9, and I love that. And you may think I'm being a little extra right now, but that's okay. I'm confident in what I'm doing. All right, and then my last step is to divide by 3. And that should bring it down a bit. There we go. So I get 439,605,247.8 equals x. So it kind of makes sense that that was such an obscenely large number, because we started with e to the 21st. So we're doing 2.7 times itself 21 times. So it makes sense that we ended up with something that was literally 1,318,000,000, etc. So don't be alarmed if you do get a large number. Sometimes if you're raising something to a large number like this, it doesn't take very long for this number here to get a little, not out of control, but just a little big for its britches. All right, let's look at this one. So I would like you to solve this one. Try this one on your own and see what you come up with. All right, so I did my spiral, and then I just followed the steps in order to solve for x. I multiplied both sides by 3 and subtracted 2, and you should end up with 488,262.3743. If you did not get the same answer, go ahead and take a pause and see how you did. See if you found your mistake. Now let's switch it up. So we've been starting with logarithm form. And so remember, I told you guys in the last lesson that if we start in logarithmic form, our answer needs to lose the log and go into exponential form. But now we're going to look at, some problems where we start in exponential form. So that means we need to do the logarithm. Now there's actually 2 methods to do this, but I'm going to continue doing what we did last time, where we take the logarithm of each side. I can show you the other method to solve this if you'd like, but for today I'd like to focus on take the log of both sides. So I'm going to write ln of e to the x plus 1 equals ln of 30. Now, I'm going to use my properties of exponents to move that x plus 1 to the front. And remember, just because there's a plus 1 there, it's still part of that exponent that we're moving. And so that means that I'm going to put it in parentheses so that I'm not tempted to make the 1 be a coefficient of ln. And then we get ln of 30. Now, this is where in the logarithm you would divide log of 30 divided by log of 5 or whatever it was. But this is why I love natural logs. What we said that the base of ln is always e. Okay, so if I write ln base e of e, this means e to what power is e? What is it? It's 1. Anytime I have some like a base and the number the same, this base and this number the same, it's going to be 1 because e to the first power is itself. Log base 2 of 2 would be 1 because 2 to the first is 2. So when you are solving something that has e to the whatever, you should be excited because that's one less thing you have to do. You can just say that's equal to 1. I don't need to divide both sides by 1. So we get x plus 1 equals ln of 30. I'm doing that in my calculator off to the side. I get 3.4012. And then I can subtract 1. And that's what I get for x. All right. Let's look at one more. What do you think my first step needs to be in order to solve this equation? I need to get the e by itself. So that means I need to get rid of this 7.2. So I'm going to subtract that to both sides. And when I do, here, I'll move this over. Where do I want that? I guess right here is okay. Like that. Sorry, there's a glare there. Oh well. Okay. All right, so I get 1.9 over here, and then it's e to the 2x over 5. And I'm going to do log of both sides. Natural log, natural log. Now, because as you start to do these more and more, you're going to be like, wait, if I'm doing ln of e to the something, I already know that that exponent needs to move to the front. If you want to go ahead and move that 2x over 5 in front, I'm going to move over here so I've got more space. 2x over 5 ln of e equals ln of 1.9. If you can recognize that this is going to become this, you can just jump right to that. You don't need to show this step here because we know that we're always going to move that exponent to the front. So, and then I know that ln of e is going to cancel out. So really, I'm going to end up with this. So I'm going to evaluate one log ln of 1.9 and get that. Then times both sides by 5. Excuse me. And I get this. And then divide by 2. So I would end up with x equals 1.6046. So it's just a continuation of what we did in the last lesson, but using these special values of e and ln. So if you have any questions about this, let me know, and we'll keep practicing together.